Hey guys, we are in our free online coaching classes for the JAM examination, and this video will be the lecture 19, and the topic is the structurally controlled landform, and this will be the part 1 video. And for this topic I had referred the books The Principle of Geomorphology, William D. Thornbury, Geomorphology by Savindra Singh, General Geology by V. Radhakrishnan. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the heading. So the influence of tectonic movements and resultant structural features of land on landform is of paramount importance. That several terminology signifies tectonic landforms, structural landform relationships like geological geomorphology, structural geomorphology, tectonic landforms and tectonic geomorphology, etc. To emphasize the significant role of structural feature in the development of erosional landform, A. L. Bloom has mentioned that it could be argued that no subaerial relief can occur until crustal uplift has raised the land above the sea level, and therefore all subaerial landforms are tectonic. So according to him, all the subaerial landforms are resultant of the upliftment of the landform, that is mainly due to tectonic forces. There are also other possibilities for the subaerial landform, that could be like a depositional landform by sedimentational deposition or by volcanic processes. So this is what his concept for the subaerial landforms. And actually all degree of transition are found between the purely tectonic and totally erosional landform, but here we are not concerned with either purely tectonic landform which is of younger than quaternary in time, or purely denudation, that is formed by the erosional or depositional landforms. Rather we are concerned with the geomorphic expressions of the tectonic movement and resultant structural feature. See, the deposition of rock in response to the fault, fold, structural, uh, homocline, or anything like that. So that is what we are going to see in this lecture. So let us see the first one, that is the geomorphic expression of an homoclinal structure. As you know, the homocline or uniclinal structure are those which represents inclined rock strata at uniform dipping angle, that is generally caused by the regional tilt. And these type of structures are formed by two way. That is one by the uplifting of sequence of off flapping coastal plain, and the other possibility is that it could be a part of a large dome or a folded structure. So the left side image shows an homocline, that is the beds are dipping towards the west if you consider this as north, or towards your left hand side. So this is how this looks when there is alternate bands of soft and resistant rocks. That is, the hard rock is less eroded when compared to the soft rocks, and the differential erosion of dipping strata of varying resistance give birth to the trellis drainage pattern. As you know, in trellis drainage pattern, the tributary join the mainstream at right angle. So this is found when there is a homoclinal structure. And there are few other typical topographic features such as scrap and wall topography, cuesta, hogback, etc. are formed on this region itself. So the river forms their valley along the soft rock beds due to the comparatively more erosion than the resistant rock beds, giving birth to the formation of strike valley. So a strike valley is one when the valley floor is just along the strike of the rock bed which is present there, while the resistant rock beds are less eroded and hence become line of asymmetric ridges which is called as cuesta, having one side of steeper scrap slope while the opposite side represents a gentle slope. So if this is a cuesta structure where you can see this is a steeper slope, well compared to this one, this is a gentle slope which is along the dip of the formation. The tributary join the mainstream, main master strike stream almost at right triangle, which caused the formation of trellis drainage. This stream flowing down the dip slope are called as dip streams, while the stream flowing in anti-dip direction are called as anti-dip streams. So with this, it is clear that the structural control of tilted strata imposes a powerful asymmetry on drainage network. The anti-dip streams are steep, short and having high gradient, while the dip stream are likely to have more gentle gradient, a larger watershed and more tributaries and more substantial flow. So this is what a generalized idea in a homoclinal structure which is presented by A. L. Bloom. So the next one is the geomorphic expression on a faulted structure. A fault is a fracture in the crustal rock where in the rocks are displaced along the plane called the fault plane. The faulting involves differential movement of strata on either side of a fault plane as a result of either compressional or tensional forces in the earth crust. The differential movement may upward, downward, horizontal, oblique, or even rotary. So the left side sketch shows the generalized parts of the fault that you can see the upthrown block, the downthrown block, the strike dip and all that thing, right? The study of fault geomorphology involves three aspects of faulting. The first one is the type of displacement of rock block and thus resulted in the fault type. The second one is the tectonic expression of the fault and the third one is the geomorphic expression of the fault. Based on the different types of movement, the faults are classified into many categories. And if you want to know more about the fault, you can check our previous video, which is exclusively for the types of fault and its origin. But that is not our main interest. The tectonic expression, that is the relief of fault, includes different types of fault scraps. That is the original or active fault scrap, the residual fault scrap, and the composite fault scrap. The scrap representing the fault plane of upthrown block is called original or active fault scrap. It may be pointed out that the tectonic relief or the tectonic expression of the fault are direct result of faulting activity that involves relative displacement of crustal rock, while the residual fault scrap is one in which there is no any further tectonic activity takes place, and composite faults are one in which after a short period of time there would be again a tectonic movement may take place. So this is a generalized theme about the tectonic expression of the fault, but our main interest is that geomorphic expression of the fault structure. So geomorphic expression results from differential erosion of fault straps and upthrown and downthrown fault blocks includes different types of fault line scrap. And there are classified as five. The first one is the normal or consecutive fault line scrap. The second one is the reverse or subsequent or opposite fault line scrap. The third one is the resequent fault line scrap, and the fourth one is the subdued fault line scrap, and fifth one is the exhumed fault line scrap. So this is the geomorphic expression of the fault line scrap. So you will see one after the other in a detailed way. So the first one is the normal or original fault line scrap. It is also known as the consequent fault scrap. Is formed due to the erosion of weaker rocks of a down-thrown block. So such a fault line scrap are oriented towards the direction of original fault scrap. So you can see in the image. So this is the upthrown block and this is the downthrown block. And as you know, the downthrown block consists of softer rock. So it get eroded much faster. And that results to the normal or original fault line scrap, or also known as the consequent fault scrap, right? And this type of fault line scrap result due to the prolonged erosion of less resistant bedrocks of the downthrow block when the process of formation of fault has practically ceased and fault remains inactive for a longer period of time. So that is the first one. The second one is the opposite fault line scrap, or also known as the reverse or subsequent scrap, which develop in the opposite direction of the original fault line scrap due to no further faulting, the erosion of weaker strata of the upthrown block of the fault. Such a fault line scraps are formed at a much later date and a relatively lower height. So you can see the image here. So this is actually the upthrown block and this is the downthrown block. But due to the prolonged erosion of a soft rock that is in the upthrown block, the upthrown side, you can see here this is like an upthrown, this is downside, right? So this is actually reversed in appearance and hence it is called as opposite fault line scrap, or also known as the reverse or subsequent scrap. It may be mentioned that it is not necessary that before the formation of subsequent fault line scrap, the original or normal fault scraps are leveled down due to the continuous erosion. The only condition is that fault has become inactive and the weaker rocks have been sufficiently exposed due to the sufficient recession of the original scrap, so that the stream may excavate the valley on the exposed weaker rocks. Okay.
Fed up with online classes? Having trouble in interaction and discussion in online classes? Looking for one-to-one learning? Then you are in the right place. GeologyAssignmentSupport.com is here to help you in your studies. For more details, check our website. Link is in the description.
The next one is the recurrent fault line strap. And the recurrent fault line straps are those that is formed due to the renewed downward erosion that is caused by the further fall in the base level of erosion. In fact, the recurrent strap result from the reversal of the subsequent strap and are oriented in the direction of the original or actually the normal strap but are much older in time, right? So this is actually the reversal of the previous case where the erosion is once again renewed by the fall in the base level. The fourth one is the composite fault line strap, and these are are those which owe the origin partly due to the faulting and partly due to the erosion. That is why it is called as the composite fault line strap. So as both act together, this represent two situations. That is the upper portion of the fault strap that is formed due to the faulting, and the lower portion is formed due to erosion. Well, the second possibility is that the upper portion is formed due to the erosion and the lower portion of the fault is created formed by the faulting. So according to C.A. Cotton, such a fault strap are formed when the fault activity become inactive and the downthrow block having greater thickness of relatively weaker formation is eroded down to a considerable depth, with the resulting original fault strap is extended downward, and thus the resultant fault line is characterized by upper faulted segment and lower eroded segment. And the alternative possibility is that the fault strap is formed due to the faulting, and after prolonged erosion, the original fault strap disappeared and the faulted region is leveled. Fall in the base level renews the vigorous erosion of a downward block and thus the formation of a recurrent fault line strap. The faulting again become active and the downthrown block is further downthrown along the original fault line, and thus the resulting fault strap becomes composite, that is consisting of upper part which is formed with erosion and the lower part which is formed with the faulting itself. Okay. So the last one is the exhumed fault line strap. It may be pointed out that in some situation the fault strap after the fault become inactive or eroded down to such an extent that the lower portion of the fault strap is buried under a thick cover of eroded material. So you can see in the left side image, the image number 1. The renewed erosion of the deposited material uncovers the buried fault strap, which is called as an exhumed fault strap. So you can see in the left side image here the fault has been buried with the sediment, and when the erosion is once again dominant, the same fault strap is appearing, right? So such a kind of an reappearing fault line strap is called exhumed fault line strap. And actually the exhumed fault line strap are usually subdued feature of which the smaller dimension of a throw of the fault. So this is what according to J. Trickett in 1974 he had mentioned this. So J. Trickett has opinion that the one important factor controlling the evolution of all fault line scrap, and that is the relation between the throw of the fault and the thickness of the hard and soft strata. Since they are product of differential erosion, they can only occur when the rocks offer sharp contrast in resistance, which is just like in a continental platform. So this will be the end of the part 1, where I'm just stopping here with the geometric expression of a fault structure. We will do the other headings like fold and dome and other things in our part 2 video. I group my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook and Instagram, and these other links. You can support us by like, share and subscribe. Thanks for watching. Have a great day.